G'day and welcome to the 7th installment of Beginning iOS Development. I am Alex Ackerman, and in this screencast we're going to dive into data management in iOS applications. Looking at how we can store data, large and small, in our applications, persistent even after we close the application. So to get us started, I'm just going to go through a quick keynote, just outlining data management on the iOS, and then we'll go into a practical implementing 4 different methods of storing data on an application. So let's get started. So this keynote we're going to look at what data do we store in an iOS application, how can the data be stored, pros and cons of the different methods of storage, and then that screencast demonstration of implementing the 4 different methods. So what data do we typically store in an application? Well, most applications that have game high scores or achievements are stored on the device. Data collected from APIs from the web. So if you are collecting information from the web, you would usually store that in a database locally so you can have it for offline storage. Then you can have products information stored on the device, whether that's already there when the application is installed or accessed from the web. Other applications store conversations, tweet messages, and basically any collection of data you can think of, you can store. So what can we use to store the data? What you're looking at here is 6 of the most common implementations of storing data on an iOS application. The first one we have is plain text and CSV. So it's creating a file that you can either split the data out into via a separator character or just storing the data just in a text file so you can read it later on. Then we have XML. You can store data as an XML document, and the iOS has inbuilt an XML parser so you can get that out into NS objects. Then we have a property list, commonly known as a plist. This is a archived file format where you would have NS objects like a dictionary, array, etc., which are then archived into an XML structure and then can be unarchived and then turned back into those NS objects when requested. Similarly, you have NS user defaults, which works in the same way as a property list does, although it has a little bit more information. It is a class built into the iOS SDK for developers to use to store quick little variables for user defaults or user preferences. Then we have SQLite, which will allow you to have a full SQL-driven database in your application. And then, last but not least, my favorite, core data. It allows you to have a fully functioning database in your application with lots of tools and features at your fingertips. Very easy to implement and very, very scalable. So in the implementation, we're going to be looking at these 4 particular methods. We're going to build a property list data store. We're going to use NS user defaults, as well as build a SQLite and core data database in an application. I'll go through the create, read, update, and delete methods in the implementation. So the pros and cons of property list, XML, and plain text documents. So precompiled or archived documents. These are great for single and non-relational or one-dimensional collections, meaning if you only have one type of data that is very easy to separate out, there's not a real lot of fuss around it, very small total data size, then this would be perfect. Storing preferences, scores, save states, and basic information from the web are what these are commonly used for in applications. And the SDK has an API for creating and reading property lists, converting them to and from NS dictionaries with relative ease. The problem with these implementations is hard to manage relational data. So if you have many different collections of data, also known as tables, if you have many different collections of data, then it's hard to relate them together without foreign key management, which these methods aren't very good for. If you have large data sets, it can become very memory intensive, remembering that when one of these files is read, opened, or unarchived, all the data for this goes into memory, it gets stored straight away, unless you're using an XML parser called SACS, but that's a specific use case, and you can come across that in your development if you want to go into XML document reading. So yes, as I said, all data is loaded into memory regardless of the amount of data needed. So only if you want one row or if you want to find one thing in the particular data set, you'll get every single one if you open up that document. and it's up to the developer to manage and create the schema, and as well as handle any corruption. So if you have a plain text document which is separated by commas, what happens if the text inside it has a comma inside it, so it splits that record unevenly and so on. So these methods are really great for very simple data sets, but if you want to get into anything harder, it's worth looking at the different implementations. So next we're going to look at SQLite. SQLite is a very light database engine. It's built around a single file, so you'll have an SQLite file, which is your database, and then you'll have a layer on top of that which then parses and reads that for you and gives you a nice API through SQL to be able to do queries and any modifications. So the pros of SQLite is it's very light and swift on the system. It can store larger data sets and handles many collections of data, so you can have many tables, you can have lots of records in those tables, and SQLite can manage it very well. It supports relationships between different collections using foreign keys, so you can have ID fields which relate from one collection to the next. And it uses SQL queries to retrieve and modify stored records, which is a common query language that most developers would know, very easy to use. The only problem with the SQL implementation in the iOS SDK, if you're not using any other frameworks with it, is the default framework is in C and not Objective-C. Not a huge problem, it's just an initial uphill struggle just to learn the different syntaxes around the C implementation. The SQL also needs to be sanitized so that if your user decides to maybe put in a bad input using commas, quotation marks, and it's not properly sanitized, you can run into problems with your database. And when the SQLite database is created, you need to manage the C database file or create one if it's not present. And so the pros and cons of Core Data. It's built and optimized for the iOS. It's been built specifically by Apple for these mobile devices. It's very light and swift in the system, just like SQLite. It supports relationships between collections, so it manages the foreign keys for you. It automatically sets up the relationships between two different records, whether it's one-to-one, one-to-many, etc. It's easy to define the database schema with Xcode tools. You have a schema editing functionality in Xcode that allows you to add new collections, add new properties in those collections, and so on. It's versioned and supports migrations through this tool, so you can upgrade your database with devices then self-upgrading themselves or have a particular migration path for changing whether you want to add a new property to a table or if you want to completely change a table entirely, you can have the migration for that change to happen. And since it's been built by Apple and it's in the SDK, it has a full Objective-C wrapper, so it's fully Objective-C and very familiar to all other iOS development you would have done. But Core Data can be overkill for a database with one collection, although it works perfectly well if you want to do an application with one set of data. I have the Core Data tutorials that are based around an application that only has one table in it. So it works perfectly well, although it is slightly overkill, but you can use it if you wish. So with all those methods in mind, you might be thinking, well, which one is best? Well, it depends on the application the data is stored. The key factors are, is the data set large or small? So if you have a lot of records, is it one or more collections? So if you have more than one table, more than one type of data, then that can influence the different type of implementation you use. Are the collections relational? Because remember, if you want to have two relational collections together, you need to have a foreign key, and then you need to do a query based on that foreign key onto the other collection. And of course, are you going to be doing simple or complex queries? So if you need to do a select on a particular table and you need to find all the records between two different dates, then obviously using something that has SQL or some type of predicate type searching ability for you is a lot better than going through an array and parsing that yourself. So now we get to the practical part of this screencast where I'm going to implement these four different methods into one application, showing you how to create, read, update, and delete data in an application. So here is our application. I'm going to open it up now and we're going to look at the interface we have. So we have 4 tab bars here: property list, SQLite, Core Data, and user defaults. These are the 4 different implementations we're going to be looking at. So looking at the interface here, we have a table view which will show the records when they are created. We have an add button to add a new record into our data store. In this particular case, we're going to add products with a name and a price. And then once that record is created, we will then be able to modify that record and also delete it. So we have a create, read, update, and delete method in all of these three controllers, and in our user defaults we have something slightly different. I'll get into that in just a little bit. So for property lists, SQLite, and core data, we're going to be storing products, and for user defaults we're going to be storing username, password, and agree to terms, because the user defaults class is not a database per se, it is more of a user settings storage place. So if you want to store a username a person has entered, a password that they've entered, or if they're whether or not they've agreed to some type of terms, you can then set this in the application. So now we're going to look at how this is implemented. Just before we begin, what I've done in this particular Xcode project is I've removed as much as the UI view controller code as possible, just to show you these create, read, update, and delete methods specifically. So I'm not going to show you how the tab bar, the navigation bar, and all those views are created. I'm only going to show you the methods that are responsible for interacting with these data methods. And also, since this application has implemented 4 different data methods into it, there is a lot of code, and when you want to implement one specifically, you don't need to implement all the code shown. So with that said, we'll just dive straight in, and I'm sure you'll understand that in just a second. So here is our main app delegate. So in our application did finish loading method, you can see that there is a lot of code, but this is only because we're implementing these 4 particular methods in this one application, which you wouldn't do. So the plist controller setup. I have implemented a zibless programming style in this application, so I'm not using any zibs or nibs, which is okay. You can, if you want, you would just create your controllers as normal using Interface Builder. This is the default code to create a new controller and to add the title and image to the tab bar. So for the property list setup, there is really nothing at all apart from the default controller setup. So when we look at the property list controller, I've implemented a few methods relating to our create, read, update, and delete. So quickly, we have an array in this particular controller called products, which will store our products for the table view to display. And in the view did load, we need to get that information from the storage on the device and then display it in the table in that particular array. So we are going to get the file. To get the file, we need to get the file path, and to generate the file path, we need to get the documents directory for the application. Because all applications are sandboxed, we only have access to a particular set of folders in our application. So to get these particular folders we can have write and read access to, we can use these methods here, which will give us the documents directory, and then what we're going to do is we're going to append the file name to that documents directory. This method here makes sure that all the forward slashes and any other path specific type characters are taken care of for us, so we don't have to worry about that. So with that out of the way, we've generated a path where the file is stored. Then we're going to check to see if the file exists. If this plist file exists, then we want to generate an array with the contents of that file. Using this method here, we can create a new array with the contents of file, and we pass it in this path. If we don't have a file existing, we're just going to create a new array. Okay, so when a user goes in, enters in information, and then wants to create that record, this method here is called. It gives us the name and price given in that modal display. So with that, we're going to create a new dictionary object with the name and price. Then we're going to add that dictionary to the array. And then once that is done, we're going to tell the table view to reload, and we're going to write the products to file. This write to products to file method will then save our NS array out into a plist file. So the update record with name is very similar. It gives us our name and price. And what we need to do is get the dictionary that we are going to be modifying. So I have here products object at index current product. Current product is the integer set on the record that we're modifying, so that when we get the information back to replace this particular object, we know which object it is in the array. Moving along, we set the name and price values again on that particular product. And then in the array, we replace the object at index, so we replace the old dictionary with the new one. Again, tell the table view to reload the data and write the products to file. And then when we want to delete the record, we just remove it from the array and then write out this NS array again. So all we are really doing is modifying an NS array, filling it with dictionaries, modifying those dictionaries, and then saving this NS array using the convenience method described here, write to file. So what write to file does is it gets our NS array, or you can also write to file NS dictionaries, NS data, and a few other NS classes. So it gets these particular classes and then archives them out into an XML document, which can be then read and turned back into NS objects. So we're going to write that into the plist path that we give it. So this, again, this path that we generate, which has this file name plist_products.plist. And we're going to set the atomically flag to yes. Just in case you don't understand what atomically means, it means that when the file is saved, it is first saved into a temporary location. So if the application quits or if the device dies during the save, then the original plist, if it exists, is not corrupted. So let's say we have a plist that already exists and we're going to overwrite it. And what it would do is it saves this new plist to a temporary location. Then it will then replace the old file. If the device dies or if the application quits during this moving process, the original plist will not be corrupted. So it saves the file from being corrupted during save processes. It's a very handy thing to have set. Then in this next section here, which I've got commented, is the table view data source methods. These are the methods that tell the data source how many rows we have in our table, what information to show in our cell when it is requested, as well as the events on did select row at index path, and around the editing using the swipe to delete method. I'm going to glaze over these because these are more implementation of how the UI view works. And you can open up this project from this tutorial and read it through yourself. Okay, so that's property list implementation. Very easy. All you do is modify a NS array or NS dictionary object, and then you use the write file to path method and the array or dictionary or whatever with contents of file method. Okay, so just to show you what that method actually creates, what I've got here is I've opened up the documents folder within the iOS simulator application, and here we can see this plist file which is created in our application. So if I open this up, we have a property list editor application in our Xcode tools. So having a look at it here, we have a array. So we can see type array here as the root item, and then if we open up these items, we have dictionaries here. So it says dictionary, and we have name and price. Looking back at our simulator, we can see that these correspond to the values here in our application. So that's what it generates. It generates a plist file, which is essentially an XML document that our application can read and write to. So looking at the next implementation, we have SQLite. Now SQLite requires a library to be included with your application. So to include this library, you would go to your frameworks folder, add existing frameworks, and then libs. Go down to libsqlite3.dylib, and then click add. I've already got it here. And then once you do that, wherever you need to reference any SQLite objects, you would import sqlite.h. So with that in my document, I can now use all the SQLite methods. Okay, so here is our SQLite controller setup section. Glazing over the controller setup we have here, we can get down to where we are setting up our SQLite data store. So As I mentioned before, the SQLite library with the iOS in its plain form without any extras or other frameworks that you may want to include is a C-based library. So you'll be using C-style functions and methods in your application instead of Objective-C with the nice square brackets. So I'm going to create a new instance of an SQLite 3 object, which is how we referenced the data store. And we need to open up a file, which is where our SQLite database is stored. So we do the same methods to find the directory path we did in our plist, and then we just tell it that we want to look for this particular file. Then in this code block here, what we're going to do is we're going to check to see if the SQLite file exists. If it doesn't exist, we're going to create it, and then we're going to seed it with a table information. So if we don't have a file at the path, because I have a exclamation mark here, so if file does not exist at path, then we want to run create file at path. If that errors out, then we'll just display an nslog error. But if that runs fine, then we want to open up this SQLite 3 document with a particular path, then storing that into the database variable we created earlier. If this open method responds with SQLite OK, then we're going to execute an SQL statement. So what we're doing here, just to step back a bit, is we need to create our schema for our SQLite database. Since we've just created a new blank file, we don't have any tables, we don't have any schema whatsoever in this document. So we need to create this. Since it's a new file, we need to create this schema. So I'm going to run create table if not exists products, giving it integer name and price columns, etc. Now what I'm going to do is I'm just going to close that database and set it to nil. So this statement here, all this does is this handles setting up the database initially. What this ensures is when this line is run, that there is a database all ready to go in the application. So this will only have to run once in your application to create that SQLite file. Once that is created, then we open up the SQLite database, giving the path and storing that into the database variable. Now, since this is a C implementation, we cannot pass an NSString object in. You'll see here I have used UTF-8 string. You'll notice that when you create a string in Objective-C, you put an @ symbol in front of it. That creates an NSString object. However, we just want a string, which is typically just done with the 2 quotes. So whenever we pass strings into an SQLite function, which is a straight C function, we don't want to give it an NS string, we want to give it just a straight string. That's why there's no @ sign in front of this here. So with all that done, we now have an instance of an SQLite database running on this database variable. Then what we're going to do is we're just going to set that onto the SQLite controller. So if I go to the controller header file, you'll see that we have the SQLite header included, and we have an instance of a variable called database, which is an SQLite 3 object. Now this object is not retained, it is only assigned. And then we have the same array and product index. Now we're going to look at the implementation for this. SQLite is slightly more code to implement, but for a larger data source, it is actually quite easy to use. So on the viewDidLoad, we are going to set the products array right off the bat to be empty. Just do a sanity check. If our database doesn't exist, we're just going to error out. And then we're going to run the method getAllProducts from database. And then just going to echo out what products we have in an array. Okay, so this next method, I'm going to have to do quite a fair bit of explaining on. So, getAllProducts from database. What this does is it runs an SQL query, gets the results, runs through every result, creates a new dictionary for that result, stores it in our array, and then stores that array. So we need to create a new SQLite 3 statement object, which I have done just here. An SQLite 3 statement object stores a query that we need to run on a particular database, and then allows us to go through that query and iterate over each row that's returned. So what I need to do next is I need to tell the statement what query it's running and on what database. So we use the SQLite 3 prepare underscore v2 method, which prepares a SQL query on the database for us. So we pass in the database we're using, the query as an SQL statement. Again, this is a C style string, not a NS string, so it doesn't have an @ character in front of it. Then we are going to reference the statement object we are using. So when this runs, it will return one of these flags here. We have SQLite K. If I just jump to definition, you'll be able to see. These are all the return codes that can come from an SQLite method running. So we have SQLite K, which means everything on that method ran okay, an SQLite error, etc. So going back to our implementation here. So if we don't get SQLite K, so if something happens, if one of those other messages is returned, then we're just going to do an NS log and return. Then, so once the statement is prepared, we have our query, it's ready to run on the database. We are going to run a while loop, so while SQLite 3 steps statement equals SQLite row. So it's going to run that query, and for each row, it is going to iterate. So in each iteration of the query that we're running, we are going to then request the 3 columns that we require. I have put in ID, name, and price as these IDs that I require. So to get these values from these columns, what we're going to do for the particular row, so we're iterating through a row, we're going to ask SQLite for the particular value for the column. We do this by running the SQLite 3 column, and then in this case, in int, I want to get the ID field, which is stored as an integer in the database. So I pass in the statement, I'm saying here's the query, and I want it at index of 0. So it's going to get me the column 0, which is in the query I've stated, so ID, name, and price. ID is index 0, name is index 1, price is index 2. So we're going to get the ID column from the statement as an integer, and then I'm going to pass that into an NS number, because we are dealing with NS objects and as well as raw C objects as well. So next one, I need to get the name. We run through NS string in it with UTF-8 string, since we need to go from a UTF-8 string into an NS string. I'm going to ask for the column at index 1, which is the name. And then for the price, I'm going to ask it for the same column. I'm going to ask it again for a column at index 2, which is price. This will return an NS string, which I then turn into an NS number using the number formatter here. So we then create a new product dictionary here with the ID, name, and then price we have in the database. Add that product to the products array, and then just release our products object. Then once we're done, we can release our number formatter, and then we can finalize the statement. So we can say the statement is now done and used. So this is a lot to take in at first. It is a lot different to Objective-C, and you do have to deal with these different object types, NS strings and not NS strings, which can create some initial hurdles straight up. It was difficult for me the first time, but then once understanding this SQLite API, how to prepare a new statement, so how to set up a query, running that query, getting all the results you need. After you've learnt that, it's pretty easy. I do recommend checking out the SQLite website, sqlite.org, and going through their tutorials looking at how to interact with an SQLite database. So getting back, we have got all the products from the database. They are stored in our global NS array for this controller, and they're ready to go. So they're displaying on the UI table view. So the next method, create new record with name. So again, we are given the name and price of a record that we have to create. So in the same way that we got all the records, we need to prepare a new statement. In this statement, we are going to do an insert. So insert into products for the columns name and price, values, question mark, question mark. This is how you can sanitize SQL queries in your application. So using the prepare method, you can pass in these question marks, and then once your statement is set up, you can then bind a value to that question mark. So for the particular statement, so the particular query we're running here, I want to bind question mark 1 with the arg name, so the name of the record that the name of the product that we're given. We're going to give that. Again, we have to convert it into a UTF-8 string. And then just two default values here. Then for the next one, we need to give it a double, which is a particular type of floating integer. Again, statement, position 2, so the second question mark, and then we're going to get arg price as a double value, which matches up with the type here. So that once we have told the statement that those are the two question marks, so it'll actually fill out this SQL query for us, properly putting in quotation marks, escaping where necessary. And then we are going to step through that again, but since it's only an insert, we only need to step through it once. So if the step, in this case, equals error, then we're going to error out. So if it runs, it's good. So if that runs and it doesn't raise an error, then it's fine. Then it's just going to finalize that statement, which is a method that you use after you finish using a statement. You'll see I've used it up here as well in the read. It closes off the statement object for you. Then once we've finalized the SQLite 3 statement, we're then going to create our product dictionary, which will be populated with the ID of the record we've just created, the name and the price. To get the ID, it's a really nice helper function here in the SQLite 3 library. So it's SQLite 3 last insert row ID from this database. So you pass in the database and it gives you the you pass in the database and it gives you the ID of the last row inserted. Then we add that product to our array and then tell the table view to reload. That's it. We have now inserted a record into the database using this query here, passing in our particular values here, and then running the statement. So when it comes to updating, it is a similar process. We prepare a new statement. We tell it the query we want to run. So we want to update product set name question mark, price question mark, where ID question mark. So we then again need to bind these particular query parameters to those question marks. So with this statement at question mark 1, we're going to give it the name. At question mark 2, we're going to give it the price. And at question mark 3, we're going to give it the ID of the record that we're going to be modifying. Then once that statement runs, we then finalize the SQLite 3 statement object and then change the NS dictionary object. So each time that we need to that we do an update, create, or delete, we then need to update our respective NS array. Then once that is done, we tell the table view to reload again. Deleting is a somewhat simpler operation. What we're going to do is create a new query. I'm just going to do this straight out as an executable SQL statement. Now again, this doesn't give you the sanitization, but if you properly control the variables you're dealing with, you can cut down on any injections that may be made. So delete from products where ID, and then I'm going to pass it in an integer, which is the ID number of the record that we're going to be deleting. Then we run SQLite 3 exec, which runs that query with no extra questions made onto the database. And if that errors out, we're going to show an error. If not, it deleted the record. So that is how you implement create, read, update, and delete into an SQLite 3 database. Now it is an initial uphill struggle if you're coming from a pure Objective-C side and you're looking at these going, I have to do UTF-8 strings, I have to manage different types of data you're dealing with. Yes, it is slightly tricky to get started, but looking at tutorials like this one, watching screencasts, etc., can hopefully help you get over that initial struggle. And SQLite is actually really easy to deal with once you've understood all those initial hurdles. So the next one we're going to be looking at is core data. Core data is something that I prefer to use in iOS development. I've done 2 articles on Mobile Tuts, which you can check out by searching core data on Mobile Tuts Plus. And it is fairly simple to set up. Now, when you set up a new project for the first time, I'll just do one here. So I'm going to go new project, iOS application. When you select your template, you want to make sure that use core data for storage is selected. This way, when your application delegate is created, you get given these methods here, which are around core data, as well as including the core data framework for you, etc. Again, to check out the initial startup guide for core data, check out my original tutorial on Mobile Touch Plus. But for this particular application, all we need to do is get the managed object context for our core data store and then set that onto our controller. Then in our controller, once we have the NS managed object context available, we have the products array and current product index. Now with the particular schema I have on this core data store, so if I go to my XC data model file, you will see that I have one entity. It is a product table, and it has two values, name and price, which is the same as throughout our application we're looking at here. So then with that, I had to create the particular NS managed object class files, which is the product class, and I have included that here. So with the product included, with all this set up, we can then go to our implementation. So for the view did load, I'm going to use the get all products from DB method. And for this, we set up a new query to the core data store. So for that, we tell it we want to get a new fetch request from the product entity, so from the products table or collection. And then we run a execute fetch request on the managed object context. So from the data store, we want to execute a search on the product table. Now I haven't set any predicates or sorting, which you can. So if you want to find a particular set of records for any particular reason for a query, or if you want to sort those arrays, you could then use the particular sorting and querying methods in core data. You can look for that in the original tutorials I did on Mobile Touch Plus for core data. Anyway, skipping over that, we have our results. They are stored as an NS array. Just a sanity check here again. If our results object is nil, or if we have an error, then we want to error out. So if we have results, we want to then store them in the products array. Here what I've done is, if the products object already exists, because if get all products from DB is already run, then we'll just release that object and then just reset it again. Anyway, in any case, it sets the products array from the results given. So for create new product with name and price, we want to set up a new product object. So for this, we do NS entity description insert new object for entity name product. So we're going to create a new product instance here in the current managed object context. So for the product, we then set the name and price, shown here. And then we just run the managed object context save method, passing in the error object here. And if we do have an error, again, we will display an NS log. If the product is successfully inserted into the data store, then we add that product to our array and tell the table view to reload. So for updating records in our data store, when the record is selected on the table view, our table view lets our controller know what row was selected and then what product was selected. So in the header file, you would have seen I have current product here. That gets set when the row is selected. So when a row is selected, current product gets set to the current row that was selected, obviously. So then we update the name and price on that object and then save to the managed object context. If an error, error out again. And then once that's done, we can then replace the object in the array with the new product that we have. And that updates the table view. Now the only method I don't have here is the delete method. I decided to put it down here in the when the delete slider is run. So when you slide across the table view and hit the delete button, this is what's called here. So we get the product at the row that was selected, and then we just call delete object product on the main object context. So that object is then deleted from our data store, and then we save our data store. If an error, error out, and then we remove it from our array. And instead of reloading the table view, I'm just going to show a nice animation instead, which will remove it from the table view. So that's implementing core data into a application. Very simple. You just have to learn the API for around core data, but it's very simple. Again, I'll plug my tutorials again on Mobile Tuts Plus. You can read through them and learn how to do all these basic operations. So the last but not least is the NS user defaults controller. So looking at this in our app delegate, there is no extra setup in our app delegate, so I'm just going to go straight to the user defaults controller. And for this, it's slightly different because we are dealing with a different setup of data. So we're not storing rows and rows of data, we are setting settings. And for this, I'm going to store a username, password, and whether the user has agreed. So I'm going to store those states into this application and then just display these on the table view. So when we want to get the values from this NS user defaults, what we do is we create a new NS user defaults object, and when we go standard user defaults, this will return all our user settings that we have previously set. So we then store that in our application. I have set it under the settings as a dictionary because the NS user defaults class has a method dictionary representation. So I'm storing that as a dictionary in our controller. And then I'm going to put in here just a quick array with the keys of the settings that we'll be using. I'll go through that in just a second. So updating. In the update method, whenever the user goes to the edit function, so if I go to the simulator, click on edit, we get this pane coming up showing us the edit. When they come back and the password has been changed, you access the NS user defaults as if it was an actual dictionary. So defaults set object, you pass it in the object for key, and then you pass in the key. So for this, I'm setting the password and the username, and then the terms, you need to store it as a string. You can't pass in a boolean, unfortunately. So I'm going to pass in yes and no as an NS string. Then you run this synchronize method, which gets your defaults that you have changed and then saves that out into the preferences file for your application. So it is essentially like the property list setup we did before, where it writes it out into a plist file. And then again, I'm going to get the defaults, so I'm going to get the NS user defaults as a dictionary, store that back in our controller, and reload the table view. So we only have the create and update method. So the create really is just setting the initial values, so whether they're blank or whether they're filled. Okay, so that is it for the implementation of those 4 different methods. It gets very interesting when you want to implement all 4 of these into one application, but hopefully I've separated out enough that it's quite simple to understand how to do these. So if you want to implement one of these methods in your application, you would set up your application normally however you want to, with whatever controller setups you wish. You don't have to copy any ways I've set up my controller here. Then you can look at these particular methods. So create, I've got create record, update record, and then you can see the particular methods I've used and the queries I've used to then create these in the particular data stores. Then you can migrate those into your own application and use that however you wish. So in closing this screencast, I just want to point out about data management on the iOS. It can be very different from application to application. There's no particular one answer, one size fits all scenario for every application. I suggest check out this Xcode project file attached with this screencast, see how it's been implemented in the code, and then run the application yourself, maybe change a few things here and there just to get the hang of it. And then when it comes around time to building your own application, maybe decide which one would be better for your application. So property lists are good for your single type of data sets. They're not relational, you don't have advanced queries, you just want to get all these records from a particular dictionary and then just display them. SQLite and core data are great for relational based objects, so if you want to get data sets over many collections, and if you want to do complex queries. And user defaults is if you want to save user settings for your application without any fuss. You can just use the NS user defaults class in the iOS SDK to save that quickly and easily for you. If you have any other questions for this tutorial, please don't hesitate to ask in the comments. I will have lots of resources to how to set up core data and SQLite in particular in your application, since they are very specific, and referencing to some earlier tutorials we've had on Mobile Tuts Plus. Thank you for watching.